Hey everyone. So I'm David Mortman, and until the end of last month, I was the Chief Security Architect and a Distinguished Engineer with Dell Software. I'm currently on sabbatical, which means that if you've been following me on Twitter, you'll have been seeing a lot of baked goods recently. It's something I do in my spare time, and I have a lot more of it now. As soon as I know what I'm doing next, I'll let you all know. But so I've been involved with the DevOps movement since pretty much the beginning. I was at a job several jobs ago, and I was embedded in the engineering team, and so I was looking, I was sort of participating, sitting in the scrums, and they were sort of evolving from Agile to DevOps at that moment, before it was even being called DevOps. And I said, hey, this is kind of a cool idea. I bet we could do this with the operations team and the security team. And I started calling it Agile Ops and Agile Security. And then people started tweeting about this DevOps thing. I said, oh, that's what it's called. Okay. And so I started speaking about the security aspects of DevOps at assorted conferences, including places like RSA and DEF CON, and elsewhere as well. And then in the last year or so, I thought, I started following this whole container thing. So is anyone here actually using Docker at all today? Oh, we have a fair number of hands. Okay, cool. So, of course, Ducey is. You're also, like me, you're buzzword compliant. In my previous job, I pretty much, if anything was sort of, I got to do all the cutting edge stuff, so it was actually kind of fun. But anyway, so what's the big deal about this whole Docker thing? Why, we've had containers for what, 20 years now, at least? And so what's the big buzz? Why do we actually care? And the reason is that Docker is, well, the cool thing about Docker and its siblings is that it gives you metadata around the construct. So it's no longer just containing your code, it's actually defining it. So in a lot of ways, what you really have is not just a container, which we've had for a long time, but you now have what is essentially a packaging format. This means that containers are now portable, which means you now have the ability to take your container from a development environment, move it to QA, move it to pre-production, move it to production, have a copy sitting in your BCDR environment, and actually have them be the same. That's pretty cool, right? I mean, one of the biggest issues that I see in DevOps environments, in pre-DevOps environments, is actually having those environments be as close as possible to each other. There's nothing worse than hearing, well, it worked in dev when it doesn't work in production, right? Or vice versa, or I can't replicate that issue that you had in production back in the dev or QA environment because they don't match up. I mean, it's hard enough when your hardware doesn't match up, but are we using the same libraries? Are we using the same code bases? Do we have the same dependencies in place? So containers really solve these problems when you have an environment like Docker that has that wrapper to define it. And now, who here does security aside from me? Anyone? Any security players? Okay, we have a couple of security people. Do you like new technology when someone comes and says, hey, I have this cool little tool? Every security person I know goes, oh, you can't do that. Yes, I have someone in the back trying to hide under his hoodie. Security people, we tend to be suspicious of new technology, of new trends, and we say, that's not gonna work. That adds a risk. Risk is bad. We don't like risk. And one of the things we've learned from the DevOps movement is that sometimes moving faster actually makes things more secure. It's sort of counterintuitive, and that's a different talk, but it means that a handful of security people, still a minority, are starting to embrace change as a positive thing. And Docker's a little scary, or it was a little scary. It's gotten a lot better. There was a bunch of blog posts, including a famous one from Dan Walsh at Red Hat saying, containers don't contain. And all the security people said, see? I told you, it's dangerous. Don't do it. Well, it's actually not that dangerous, it turns out, and I'll get into that more as I go on. But the fact is, there was a handful of really cool blog posts of people showing how you could leverage access from a Docker container and get root on the machine. Because when Docker was first shipped, it really wasn't that secure. And you know what? The Docker folks knew that. They said, this is test code. This is a cool idea. Be careful what you do with this. Don't run more than one container on a system, and don't run it as root if you don't have to.
But people said, and there was a handful of folks who were very sophisticated who went ahead and started using it and were comfortable doing so. And a lot of folks started using it going, woo, new tech. And the security people were all hiding in the basement with a paper bag, breathing in, hoping nothing bad happens, and at the same time doing shots probably, in hope something really doesn't happen. But it turns out, like I said, the Docker folks knew this, and over the last year, they keep publishing improvements, code fixes. They've addressed the issue, most of the issues. In fact, they've addressed all of the blog posts and public conversations about easy ways of getting out of Docker containers. So in fact, they kind of do contain. And for the most part, it's really, unless, it's actually pretty hard to get out of a container. There are a few exceptions, but they're hard to use. And you can address those, and I'll tell you how to do that in a little bit. I don't want to say everything at once. There was an awesome thing. Like I said, getting a little ahead of myself in my slides. Let's go. So let's talk about what security features there are today in Docker. So first of all, when you think Docker security, you should think about containers, think about VMs, think about cloud security, think about the concerns that are there around virtual machines and whatnot, and you basically the same level of concerns, plus a few others you need to worry about with containers. So who here uses VMs on a daily basis? Everyone, right. Who here uses any Amazon, Google, Azure, OpenStack? Well, a lot of cloud users here too. Anyone go out of business? No hands. Guess no one from Cloud Spaces was here. Oh, shouldn't have said that. That wasn't a cloud problem, though. That was bad credential management problem. And what you have today on top of that is, to help with containers, Dockers, there's namespaces. Namespaces restrict what you can do. It sort of mimics having a virtual machine-like environment. And with one exception, there's a lot of great namespaces. They're all in the kernel, and they restrict what you can do. And there's network namespaces, and there's process namespaces. The one thing that's only just come in now is a user namespace. And user namespaces are particularly important because user namespaces let you remap users from one UID to another UID. This means that if you have a functional user namespace, which is now available in the Linux kernel, and it's available in the experimental branch of Docker as of a few weeks ago, you can remap what the container thinks is root as a non-root user outside the container. Now this is huge, because this means that if you're running a process as root in your container, and someone manages to escape today, they actually have root on your machine, on your VM, or your bare metal underneath. That's bad, right? Yeah, that's bad. No one likes that. But once user namespaces are more functional, they're in sort of phase one, it's experimental, as I said, those user namespaces will allow you to say, map it to a regular user who doesn't have any particular privileges. That's better. It means that it restricts the kind of damage that a user can do should they manage to escape the container. So that's pretty cool. There's C groups. Question? By the way, if you have questions, just raise your hand. You don't need to wait to the end. There may not be time for questions at the end. So if I'm going too fast, going too slow, snide comments, especially from this guy, just throw them out there. So there's C groups. Those let you gather processes and things like that, resources into convenient little packages, so it's really easy to understand what your container is going to do. Pretty cool. You get dedicated network stacks. And then here's the cool security feature you get today. So about 9 months ago, Docker gave the ability for official Docker images to have the manifest signed. So that way you would know, hey, this is the container I think I'm getting, sort of. Because the manifest would be signed, but didn't say anything about what was in the container itself. And then they released Registry 2.0 back around June, July time frame. And they completely redid the registry format, and they leveraged what's called the update framework. Anyone familiar with the update framework? Okay, so the update framework is designed to be a secure package management delivery mechanism. And one of the things the manifest for Docker has now, so the manifest says, here's what your Docker container looks like, here's what's in it. Here's the software that's inside it, so that way you basically can build your container and run it. With Registry 2.0, which is the default now, for when you create a new Docker container. That manifest now has signatures, has hashes rather, of all of the subcomponents in there. which means that when you download your manifest and you check the signature on the manifest, you know that what's inside the manifest is actually what's inside your container. So this means that once you find a container you like, whether it's a publicly shared one or one you create, next time you download it, you actually know you're getting the same thing again. And that is huge. You need that repeatability. You need to know when you have variation, as our previous speaker pointed out. In this case, you don't, for the most part, you probably don't care why that container changed. You need to be aware that it changed from a security perspective. So then you can investigate why it changed, whether it was and then determine whether was this a legitimate change or not. But this means you get consistency, more security, that's all good. So that's an awesome improvement that they released in the last few months. Now, we get into the fun part. This is where Docker gets hard. I like to say, when I talk to folks about this, is that there's a lot of operational concerns when you want to go ahead and really lock down Docker and run it securely. And the big issue is, from my perspective, is that still really a solution to really do it the way Docker recommends is really, unfortunately, for the 1%, the people who are incredibly mature, who have good, solid processes around dealing with this stuff, because there's still a lot of manual processes here. And you can automate some of this, but it's not easy. And so to do everything they say, you need to be really, there's a whole lot to do. So some of it's pretty straightforward, like say, lock down network traffic between containers. I mean, this is sort of, a lot of this is security 101 type stuff, but you still need to do it. And by default, people don't do this in their environments. They tend to allow pretty much everything to talk to everything within subnetworks. When you have containers, whether they're running on the same machine or across machines, restrict the network traffic between containers to the ones that they need to run on. IP tables, virtual firewalls, it depends on your infrastructure. This is all doable today. Turn on audit-D for the actual Docker files and network configurations. And then, I know this is crazy, monitor the logs. There's a few people out in the hall who I hear are doing log stuff. But yeah, you actually have to look at the logs, otherwise they're not so helpful. Otherwise, all you do is have a big pile of disk taken up that could be doing something else. Then only use SSL TLS-enabled registries. This is the default. Don't turn it off. Really, it's not that hard to, if you're doing a private registry, get a cert. Make your own cert, but don't turn it off. It's not that complicated, people. Don't let the Docker daemon, if at all possible, don't have the Docker daemon itself listed on a network port. For the most part, there's not a lot of need to do that. And if you do it, enable TLS authentication. Don't be throwing those credentials around in the clear. And I know there's some people sitting here going, this is security 101. Yes, it is. But you know what? A lot of people aren't doing it. It needs doing. It's not on by default. You have to turn it on. I know. I find it boring too. But you got to do it. Lock down the actual Docker configuration files to be owned by root. Make sure the permissions are 644. By default, there's no one needs to write to those config files except for root, realistically. If at all possible, run your containers as a non-root user. If there's a security issue in Docker itself, in this sense, throwing root out there for people. Right? Okay. Let's get to, minimize your package installs. Containers are supposed to be lightweight. Ideally, in a magical ideal world, it would really be one process type per container. You don't need your entire application stack in one VM, generally speaking. You don't need them all in one container either. That sort of, it violates the sort of concept of containers. Containers really direct you towards a microservices style environment. I like to think of containers and microservices as the sort of network version of the Unix philosophy. Okay. One tool does one thing and it does it really well. There's not so much of a pipeline because it can be multi-directional and all that, but it's the same general idea. Keep your containers small, they're more portable, they're easier to audit, they're easier to figure out what's going on, easier to figure out when things break, it's easier to figure out what's going on. Let's see what else we got here. Don't use privileged containers. Now, privileged containers are ones that generally you do root level functionality on your box. There's almost no reason to run a privileged container. Occasionally there's some excuses to do it. Minimize the use of privileged containers whenever possible. Set things like memory consumption limits. Don't let someone use your Docker container to DDoS your box. Anyone who's doing Java, anyone doing Java stuff? Wow, not as much as I was expecting. Yeah, we're already used to that. When using VMs, JVMs or elsewhere, we're already used to setting reasonable memory limits, minimums, maximums. Do the same thing for Docker. Don't be the tool of your own downfall, basically. Here's one. Mount your root, the root partition of your container, read only. It's a good general practice, whether you're running containers or not when you think about it. Don't mount critical file systems from your underlying host to your Docker container. Your Docker container doesn't need to see the real etc, for instance, or proc or things like that. Okay, so here's one crazy one. Everyone ready? Backups. Yeah, I have someone in the back going, really, back up your shit. Yeah, I know. Who likes doing backups? Yeah, no one. Document where things went. Document what things look like. Boring, but necessary. So use trusted containers. Know where your containers come from. Whenever possible, use a 2.0 registry so you get that update framework mechanism. So that way you get those signatures, you know what you have. You can run a private registry with 2.0. So there's not a reason, you're not restricted to public registries for this stuff. Okay, keep your underlying container images patched. Yeah, I know, but it's a container. I don't need to patch it. So in some sense you could say, don't patch your containers, build new ones. Containers are great for moving to an immutable infrastructure environment. Anyone do that? I love immutable containers. We have a handful of folks. And here's where I got a lot of shocks when I talked about this at a previous conference. And I apologize to the sponsors in the room. Don't run Chef or Puppet. Don't run CF Engine. Don't run a configuration management tool inside your container. It violates several principles. It violates the principle of only one process per container. It makes your containers bigger. And most importantly, containers should be immutable. Netflix has talked extensively about this at the VM level, the AMI level on Amazon, but it's the same general principle, which is when you need new stuff, build new containers, build new images. It makes it much easier to migrate. It makes it much easier to say, okay, I think I have the new fix here, I'll build a new container, I throw it live. If it doesn't work, I don't need to roll back anything, I just redirect my load balancer to the old containers. You avoid configuration drift, you avoid rollback issues, you know exactly what you have, and you don't have the issues around, you don't have nearly the potential issues around change management databases and whatnot. So don't use those. It helps address attribution issues and whatnot as well. It gives you some better change management because then you can actually log who created the new container using you can actually use your same continuous deployment tools, your Jenkins, your whatnot, to actually deploy your containers. So you still get that logging, that auditing of what changes happened to the same degree you do with traditional configuration management tools without the extra weight of those tools. And then you get to the really fun part. And this is where things get hard, where the work comes in. It's highly recommended that you use AppArmor and/or my least favorite Unix tool in the history of Unix, SE Linux. So here's my process for using SE Linux. I turn it off. Unfortunately, given the state of containers, you should really turn it on. The vast majority of people I know who encounter SE Linux do what I do. They turn it off because it breaks shit, right? Anyone actually like SE Linux? Whoa. We have 2 people, 3. Do I have 4? 4? No, 3. Okay, we have a few people who like SE Linux. Thank you, bravo. You're braver than me. It's better than nothing, it's true. So one of the cool things so use SE Linux, use AppArmor. The great thing about SE Linux is it does help protect some of the broader issues that some of the escapes that still exist can be addressed just by turning on SE Linux. Is once you figure out that your configuration that's ideal for SE Linux and AppArmor, it travels with the container. So you don't need to keep recreating it every time you relaunch your container. It travels with the container. So once you get it working, you don't need to recreate it every time. But it's a challenge. So we had 3 people in a room. We have, 150 people in the room? About 2% of the room likes SE Linux and probably can use it successfully. So maybe it's a 2% solution, not a 1% solution. Use SE Comp. Anyone familiar with SE Comp? Okay. Another, the same brave soul. So SE Comp is a really cool tool that lets you very granularly restrict what libraries can do. Not just which libraries that your system can call, but what subfunctions the library can call, what parameters system commands can call. So it lets you really narrow the scope of what containers can do and what can happen inside containers. So that's pretty cool, right? That's really powerful, but it's not easy to use. So that's pretty exciting. On the easier front of things is, so there's so a lot of these recommendations came from the Docker CIS benchmark. CIS publishes benchmarks for operating systems and network stacks and whatnot to tell you how to deploy them securely. And the document's like 190 pages. I read it so you don't have to, which is why you get all these. I'll post the slides somewhere afterwards so you can get the contents all in the speaker notes. They released a tool called Docker Security Benchmark. It's on GitHub. You can just run it against your container and it'll tell you which of the recommendations, and these are the highlights by the way, which of the recommendations you are hitting and which ones you're not, and tell you how to address them. So that helps with some of that. It doesn't help with the SE Linux configuration issues or things like that, but at least highlight where pieces are missing, like reminding you to turn on TLS authentication to the daemon and whatnot, things like that. There's a cool tool coming out that's out now called LXD, which is the LXC daemon, and what it effectively is a hypervisor for running Docker. So this way you don't have to have a full-fledged underlying operating system. So it's similar to a virtual machine environment where you have, rather than running a full guest OS like you might on your desktop, in a server environment you run your thin little hypervisor. And LXD is essentially a container hypervisor to restrict the underlying attack surface. So that's kind of cool. So that came out 5 months ago or so, and so it's still experimental, but you should check it out. If you need something really hardcore, Apsera is it's a commercial product. I haven't had a chance to really dig deeply into it, but it enables you to apply lots of policy and additional security for containers and platform as a service environments and things like that. So that's probably worth investigating as well. There's things coming. I already talked about the V2 registry, actually. That's out now. User namespaces, that's the big thing. In 1.9, they're hiding in the runc, which is underneath the underlying components that make Docker work. And user namespaces are now available in the experimental branch as well. So start poking at them. They're doing a multi-phase approach. GitHub has the full list of what the phases look like and whatnot. I really, unfortunately, do not have time to dig into all those since we have about 5 minutes left. So what's left? What's left for them to do? Where are things missing? One of the issues that still hasn't been addressed yet is that the kernel keyring isn't namespaced. So any keying information, credentials, cryptographic secrets, SSL keys, things like that you put into the kernel key space as on the host OS are available to every single container. Oops. Oh, and by the way, if you as a container put something in the kernel keyring space, it's available to every single container. This is a good reason to run one container, or at least one container type per VM. If you run SE Linux, that automatically addresses that for you, so that's cool. If you're afraid of SE Linux, like I am, be really careful about how you manage secrets on your machines. There's 2 open source projects for managing secrets. both in a VM and container environment, not specifically just to Docker. There's Vault from HashiCorp, which is pretty cool. I've started poking that a bit. And there's also KeyWiz, which came out of Square. Both are designed for securely passing secrets around things like SSL keys and other cool credentials like that. So check those out. Those are some great open source projects for helping manage that. Last I checked, which was a couple weeks ago, the Docker API still had no authentication. None. No authorization. When you connect, you have full root level privileges to that container to tell it to do whatever you want. That's bad. This is why one of the recommendations made earlier was not to expose that Docker daemon to the network. By the way, I forgot to mention earlier, don't SSH into your container images. Locking down SSH sucks. It's a nightmare. It adds a lot of attack surface. I have the security wall going, yeah, turn it off, turn it off. There's a built-in tool called NSEnter that gives you the same ability to get into the container when you need to poke at it. But mostly, you have logs. Record them. Look at them. I know, it's crazy. Why would I look at logs? But yeah, the API doesn't have any authentication on it yet, so that needs addressing. That's on the roadmap. Things need to be made a lot easier. SE-comp is still too hard. AppArmor is too hard. SE Linux is too hard. We need to make it easier for people to configure these and figure out what's going on. So that's still a bunch of work. Getting logs out of, getting the containers to log well is kind of a pain. Getting containers out of logs, getting logs out of containers rather, is kind of a pain still. We need to make that easier. Orchestration, which I really don't have time to get into, unfortunately, is still a huge problem. Kubernetes, Mesos, et cetera, still are pretty lightweight on the security front. I was talking with a friend a couple weeks ago, and he's like, do you know about kubectl? I'm like, no, tell me about kubectl. The security guy in the back is cackling now. I guess you know about that, huh? He's going, yeah, it sucks. I hate technology. I'm gonna go drink. He's like, yeah, let's go. So this friend of mine, he's running security for a startup out in Austin. And he's psyched. He has Kubernetes installed. He feels like he has that sucker locked down, and he has his Docker containers locked down, and his devs are like, check this out. I just got root. kubectl is a really cool tool that lets you just jump in and start managing shit. There's no authorization. If you have access to the command, you can do whatever you want on any container, anywhere that Kubernetes can touch. And so he did the appropriate thing, and he put in a pull request to get, he opened an issue asking them to fix it, but it's not fixed yet. It'll probably be a while because it's not an easy thing to fix. Pretty much all the orchestration frameworks have similar conceptual tools because they're useful, and like most new technology, security gets bolted on later on, which is not inherently a problem, but you need to know about it. So watch out for things like kube control. Keep an eye on the security discussions around these tools because there's still a lot of work to be done there and whatnot. There's a whole lot of resources. They're in the speaker notes because the URLs are too ugly to put on screen. It will make the baby kittens cry. But it has the full list. But the notes there have the full list of where to find Docker security benchmark and the CIS benchmark for Docker and a bunch of other white papers on Docker security and whatnot. And I'll update it to include the pointers to the Kubernetes and Mesos security documentation as well. And I have time, I think, for like one question, unfortunately, or I can just let you have that whole 45 seconds back before the next sponsors come up.
So you mentioned one of the pros that they're repeatable.
Yes.
So why back
That's a great question. So the question was if one of the great benefits of containers is repeatable, why back them up? That's a great question. Actually, you don't necessarily need to back up your running containers. That's probably actually redundant, but back up your registry. You don't want to lose the container. You don't want to lose the source container. Thank you for that clarification. Okay, well, thank you very much for having me, and I'll be around for a little while if you want to ask me questions privately.